Kilo Zero Bravo Oscar Tango K0BOT. My name is Dick Delta India Charlie Kilo. Over.
Getting on the air quickly after earning your first amateur radio license is one of the most important steps you can take as a new operator. Operating your radio soon helps turn what you studied for the exam into real, practical skills. The sooner you begin transmitting and listening on the air, the more comfortable you become with radio controls, operating procedures, and on-air etiquette. Early operating also builds confidence. Many new operators hesitate because they are worried about making mistakes, but those skills improve fastest through experience. Making your first contacts, even simple ones, reinforces what you've learned and shows you that amateur radio is meant to be used, not perfected before you begin. Getting on the air quickly also connects you to the amateur radio community. Through real contacts, you'll hear how experienced operators communicate, handle call signs, and exchange information. This exposure accelerates learning and provides encouragement, mentorship, and motivation to continue improving. Finally, early operation keeps enthusiasm high. Amateur radio is a hands-on hobby, and momentum matters. By getting on the air soon, you transform your license from a piece of paper into an active skill, laying the foundation for long-term enjoyment, learning, and service in amateur radio. Getting on the air doesn't have to be expensive. A low-cost handheld transceiver, often called an HT, combined with a simple quarter-wave antenna can dramatically improve your ability to reach out to local repeaters. While the antenna that comes with most HTs is convenient, it is often a compromise, and replacing it with a properly sized external antenna can make a noticeable difference in range and signal quality. Building a simple quarter-wave antenna from inexpensive materials allows new operators to focus on learning and operating rather than spending money. This approach keeps costs low while providing real, practical improvement in performance. With a basic HT and a homemade antenna, many new operators can reliably access repeaters that were previously out of reach, making their first on-air contacts easier and more enjoyable. For operators on a budget, this combination removes one of the biggest barriers to getting started. It proves that amateur radio doesn't require expensive equipment to be effective, and it encourages new licensees to get on the air quickly, build confidence, and begin learning through real operating experience. This video demonstrates how to build a simple and effective quarter-wave ground plane antenna using an SO239 panel mount connector and metal coat hangers. This design is popular in amateur radio because it is inexpensive, easy to construct, and performs very well on VHF and UHF frequencies. With only a few basic tools and readily available materials, you can build a reliable antenna suitable for local repeater and simplex operation. The antenna consists of two main parts, a vertical radiator and 4 ground radials. The vertical element is the active radiating portion of the antenna, while the radials act as a reference ground that completes the antenna system. Together, these elements form a balanced quarter-wave antenna that is efficient and easy to tune. Because most of the repeaters in my area have 2-meter receivers, I will use the 146 MHz measurements, which is the 2-meter frequency band. Before starting the build, let me help you understand why this antenna is so effective by talking about its radiation pattern. A radiation pattern shows how an antenna sends and receives radio energy through space. Instead of radiating equally in every direction, most antennas have areas where the signal is stronger and areas where it is weaker. A radiation pattern is like a map that helps us see where the antenna performs best. For a quarter-wave ground plane antenna, most of the signal is directed outward toward the horizon, which is ideal for talking to repeaters and nearby stations. Much less energy goes straight up into the sky, so the antenna is most effective for local, line-of-sight communication. Understanding the radiation pattern helps a new amateur radio operator choose and use an antenna more effectively. It shows why height, orientation, and surroundings matter, and how positioning the antenna well can improve coverage, signal strength, and overall performance on the air. Now we can get on with the build. Let's start with the heart of this antenna, which is a panel mount SO239 connector. This is a female UHF radio frequency connector designed to be mounted through a flat surface, such as a metal panel or enclosure. It provides a strong and reliable connection point where a coaxial cable can attach to an antenna or piece of radio equipment. The SO239 connector mates with a PL259 connector, which is commonly found on amateur radio coaxial cables. Because of its mechanical strength and dependable electrical grounding, the panel mount SO239 is often used as an antenna feed point, especially in home-built antennas like the quarter-wave ground plane designs. It allows the antenna elements to connect cleanly on one side, while the coaxial cable connects securely on the other. This antenna build calls for the following hardware: 4 screws, 4 nuts, 4 washers, and 4 electrical connector rings, and 1 shrink tube. In addition to the tools already shown, you will need a heat gun, hair dryer, or butane torch for the shrink tubing. If you have never used shrink tubing, heat it until the adhesive glue begins to come out of the ends of the tube. Move the heat source around. Do not hold it in one spot for too long. Overheat the tubing, and it will burn. The assembly of the radiator requires a solder iron. At this point, I cringe. I worry students will be scared off at the prospect of using a solder iron. If you have never used a solder iron, this is your chance. It is only one weld. And last but not least, don't forget the tape measure or ruler. For anyone who is adverse to math, these are easy measurements. And if you don't like your tape measure, I'll show you how to make it into an antenna. To begin construction, cut the neck off all 5 hangers. Straighten out the hangers. After you complete this step, measure and cut each of the 5 hanger wires to a length of 20 inches. When the wire is mounted on the connector, it will be measured and cut down to a length of 19 5/16 inches. The remaining hangers form the 4 ground radials, each measuring 20 inches. Whenever painted metal is used in making an electrical connection, it is important to remove the paint to increase conductivity. On one end of each hanger wire, file off the paint. The 4 filed ends of the radials are inserted into the electrical rings, and the filed end of the radiator is inserted into the connector plug. Add an electrical ring to the end of each radial. This allows for easy connection to the SO239 connector, as well as making it easy to take down and store when not in use. There are 2 problems with using the electrical rings on the end of the radial. The first is the amount of effort and hand strength necessary to apply the electrical connector to the hanger wire. The second and more important issue is that the metal on the electrical connector is soft, leading to the weak metal becoming unable to maintain the necessary angle for transmission, along with the metal breaking after being bent up and down. It has a short work life. When applying problem-solving techniques, the idea is to prevent or mitigate predictable equipment failures. For this reason, I prefer the alternative. Use a needle nose pliers or locking pliers like this one to bend the wire to make a ring for connecting it to the SO239 connector. The hanger wire is very stiff and handles repeated bending well. It has a long work life. As an amateur radio instructor, I have helped many students build a quarter-wave antenna, so many so that I found it necessary to build a jig. I found out through experience that trying to keep everything in place while soldering the hanger wire into the center plug of the connector can be difficult, especially since I only have 2 hands. So watch how it works. The SO239 panel mount connector is resting in a hole on the jig. The hanger wire drops down through the hole in the top arm of the jig, and the radiator wire rests in the center plug of the connector. Gravity works. The antenna is frozen in place by a plug inserted in the top hole, which pins the antenna wire in place. I can now solder the connector and wire together. In this step, I place the shrink tube on the wire to provide stress relief for the solder joint. Heat is applied to the shrink tube, bonding it to the connector and wire. I use automotive shrink wrap. It is designed to work in extreme environments of hot and cold with minimum failure. It is stronger and more durable than regular hobby shrink tube. Now it's time to trim the radiator wire. Make sure that the end of the tape measure is resting on the connector. Apply a dot of white correction fluid where you want to make the cut. After this is done, it is time to add the radials to the connector. Each ground radial is attached to the flange of the SO239 connector using small screws, nuts, and washers. Insert a screw from the bottom of the connector. Now on top of the connector, add the radial ring, a washer, and a nut. Tighten hand tight. Make sure that each radial is aligned with each corner of the flange on the connector. Tighten with a screwdriver. Gently bend the radials downward until they are at a 45-degree angle from the antenna mast. By bending the radials downward, the impedance increases. As the radial angle approaches about 45 degrees, the impedance typically moves closer to 50 ohms, improving the match, lowering SWR, and allowing power to transfer more efficiently from the radio to the antenna. After assembly, all connections should be inspected carefully. The solder joint at the center pin should be solid, and the radial mounting hardware should be tight. The vertical element should be straight, and the radials should be evenly spaced around the connector. At this point, the antenna is electrically complete and ready for testing. Before transmitting, basic safety practices should always be followed. Place a small strip of colored tape at the end of the radials. The wires are difficult to see and can cause injury if someone walks into them. The antenna should be mounted securely and kept well clear of people, pets, and overhead power lines. Never install or adjust an antenna near energized electrical wires. When testing indoors or at low height, transmit only at low power to avoid excessive RF exposure and interference. SWR tuning is an important final step. Connect the antenna to an SWR meter or antenna analyzer and check the standing wave ratio across the intended operating frequency range. If the SWR is lowest below your target frequency, the vertical element may be slightly too long and can be trimmed in very small increments. If the SWR is lowest above your target frequency, the element may be too short. Adjustments should be made gradually, rechecking SWR after each change. Please note, I built a 2-meter version of this antenna many years ago as my first antenna. I did not have an antenna analyzer at the time and used it in my backyard for a summer successfully to contact a repeater 40 miles away. I found that if you stay true to the cut length of the radiator, it can operate without tuning. This is a very forgiving antenna design and easy to make for emergency use. The angle of the ground radials can also be used for fine-tuning. Increasing the downward angle generally lowers impedance, while raising the radials slightly can increase it. Small adjustments often result in noticeable improvements, so patience is key. Once the SWR is within an acceptable range, the antenna is ready for regular use. Despite its simplicity, this quarter-wave ground plane antenna provides excellent performance and serves as an ideal first antenna project. It also offers a valuable hands-on way to understand antenna fundamentals, tuning, and safe station practices. Now it's time to mate the antenna to the radio. To accomplish this, I am going to use RG8X coaxial cable with a PL259 connector on one end and a SMA female connector on the other end. This is called a transition cable and allows me to replace the rubber duck antenna with the quarter-wave antenna. The point where the connector meets the antenna is called a feed point. This picture shows how beautiful it looks with the PL259 connector attached. Now it's up to you to build the mast for mounting the antenna. Building your first antenna is more than just a technical exercise. It's your first real step into the amateur radio airwaves. With a simple 2-meter quarter-wave ground plane antenna, you've learned how to measure, cut, assemble, and fine-tune a design that is both practical and reliable. This antenna is forgiving, versatile, and capable of real communication, whether you're reaching a local repeater, making simplex contacts, or preparing for emergency use.